Welcome to Chapter 2, where we're going to focus on technology. In Chapter 1, we talked about science as a way of studying and explaining the natural world. This chapter takes the next step and asks what happens when we use that scientific knowledge to solve our problems. As we move through the chapter, keep in mind that technology does not only mean phones, computers, or electronics. Technology can be an object, a process, a skill, or even an organized system that helps people use or is used to accomplish a task. We will also look at how technology affects society, why responsible design matters, and how engineers move an idea from a problem to a finished product. The goal is not to memorize a list of inventions. I want you to be able to look at something people have created and explain what need it addressed, what trade-offs came with it, and how science and society both influenced its development. Science and technology are closely connected. But what is technology? They're not the same thing. Science is a process we use to explore and explain the natural world. Technology is what happens when we use scientific knowledge to solve a human need or problem. It could also be a non-human need, to be honest. The pen on the slide is a pretty good example. We probably don't think of a pen as an advanced technology because its familiarity and its simplicity, but it's absolutely a technology. People had a need to record information quickly and reliably. So a pen combines materials, design, manufacturing, and knowledge about how ink behaves in order to meet that need. So when the slide asks, is this technology? The answer is yes. We do not let the word technology make us think that it's only something digital. A hammer, a pencil, a water filter, a bridge, and a smartphone are all technologies if they are human made solutions to a problem or need. Forms of technology. Technology can take several different forms, and it's important because it helps us from defining technology too narrowly. The first form is a human made object, like a radio. That is the kind of technology most people picture first, but technology can also be a method or a technique for making something. The process used to make glass is technology, even though the process itself is not an object you can physically hold. It can also be knowledge or a skill needed to operate man made objects, such as knowing how to pilot an airplane. So, finally, technology can be an entire system of people and objects working together to complete a task. The internet is a great example. From the over the top image we have right here, it's meant to get your attention, but the internet itself is not one single machine. It depends on computers, cables, servers, software, networks, and all the people working together. That entire system is a form of one technology. You're going to have a fun time saying this one. Agricultural biotechnology is a branch of technology used to create, improve, or modify plants, animals, and microorganisms. The goal is usually to produce traits that are more useful for us, usually in consumption. For crops, that might mean better resistance to drought, insects, or disease, or it might mean producing more food for the same amount of land. With livestock, people may select or develop traits used to make a greater size, change growth, speed, alter health, or increase production. The animals in this image help show how different traits can be emphasized. The important idea here is that once humans have the ability to influence these traits, we also have to think about the consequences of doing so. That leads to the question at the bottom of this slide. Just because we can modify plants or animals, should we? There is not one automatic answer. A responsible decision has to consider benefits, risks, animal welfare, environmental effects, food supply, costs, and the needs of society as a whole. Technology gives us possibilities, but then we still have to decide how those possibilities should be used. All right, so moving on to section 2, the first part of the chapter that we've just finished focused on what technology was and its different forms. This section will shift our attention to the relationship between science, technology, and society. As you go through this section, pay attention to the fact that technology does not develop in isolation. What people value, what they buy, what problems they solved, and what consequences they're willing to accept can all affect which technologies are developed and which ones are not. Science and technology and society, they all play a large role in each other. Society is a group of people who share similar values and beliefs, and society has a major influence on technology. One of the most direct ways that happens is through consumption. We are all consumers. We must consume. When people choose to buy a product, they're supporting these companies and technologies behind that product. You guys all love Apple. The phones on this slide that are all very old, I think that's an iPhone 5 and a Samsung Galaxy. It's old. Uh, they're a great example. If millions of people want faster phones, better cameras, and longer battery life, or whatever the other new features are, companies have a strong reason to spend money developing those improvements. If people stop buying a certain type of product, like a flip phone, development may slow. It might even move to a completely different direction. Look at the Wii U. This creates a feedback loop. Technology changes what society can do, but society also changes which technology get attention and investment. Think about how quickly phones have changed in a relatively short period of time. 20 years ago, we had flip phones. Most people didn't have a phone. To now, almost everyone has a phone that can take pictures, go on the internet, and do a lot of other things that were almost impossible or so expensive they were not accessible to the normal human. So, all of those scientific and engineering advantages made that possible, but also the consumers continued to demand and purchase new versions of the things that they wanted. Technology that is new can have positive effects, but all technology can also create risks and unintended consequences. That is why the slide that we're on here will emphasize being environmentally and culturally responsible when new technologies are introduced. You might be a little bit before all of our times, at least Chernobyl. I was alive for the BP oil spills. Uh, we've got two major examples, the BP oil spill and Chernobyl. These are examples of situations where technology, human decision, and failure had a serious consequence. The point for these kind of slides isn't to bum you out, but it's to show that technology itself is automatically not good or bad, but it's almost always automatically dangerous. It's the largest point, if we zoomed out as far as we can go, is that powerful technology, regardless of size, can affect large numbers of people and large areas of the environment when something goes wrong. Responsible use means thinking beyond the immediate benefit. We should ask what could fail, who could be affected, what environmental damage is possible, and whether safeguards are strong enough. A good technology solves a problem, but a good decision-making system also tries to prevent the solution from creating a larger problem somewhere else. Think of all the ducks. Rest in peace. Alrighty, here we are, section 3. So we've looked at what technology is, how it affects society, and the development of new technology. Now we're going to focus on more directly how technology is designed and brought from an idea to something people can actually use. This is where engineers become especially important. As we move through the remaining slides, pay attention to the steps between identifying a need and producing a finished product. A useful idea still has to survive design limits, testing, revision, production, and cost before it ever reaches a consumer. Engineers, more like big nerds in white shirts, am I right? An engineer is a researcher who helps bring technology to the consumer. In practical terms, that means engineers design and create technology to meet the needs of society. This engineer shows nerds, known as engineers, working around a vehicle system. Notice that the engineer is not just sitting down and inventing a finished product in one attempt. Engineers have to understand the parts of a system working together and then use scientific and mathematical knowledge to evaluate their designs and then solve problems when the first idea doesn't work as expected. A major part of engineering is turning a need into a workable design. If society wants a vehicle that is safer, more efficient, less expensive, or easier to maintain, an engineer has to figure out what changes can realistically accomplish that goal. That means engineering is where scientific knowledge gets translated into a practical solution. You can tell because that guy is using a laptop from 1995. Design and technology. Designing technology involves more than simply asking, can we build it? Yes, we can. The scientific method asks to test those ideas, and engineers have to work with constraints. Constraints are the restrictions placed on a design by any outside factors. The most obvious constraint is cost. You may be able to design an amazing product, but if it costs more than anyone can afford or is willing to pay, it may not be useful. Materials are another constraint. A material may be too expensive, too heavy, difficult to obtain, or unable to handle in the conditions that would be safe for the product. Size, time, safety, and available equipment can also limit a design. Once a design is chosen, a prototype is built so the idea can be evaluated in a more simplistic and realistic form. The concept car on this slide shows how designers can explore features before fully committing to production. A prototype gives engineers something they can test, inspect, revise, and look at in different ways before large amounts of time and money are spent making the final product. They're like a model. The final steps. Are you going to steal diesel emissions information? I might. After a prototype is built, the design is still not finished. Scientists and engineers use simulations and physical testing to see how a product performs. If a test reveals weakness, they can return to the design, change, and then test again. That cycle happens many times. Before full-scale production, though, this slide introduces the idea of a pilot plant. A pilot plant is a smaller scale version of the production equipment that allows the manufacturing process to be tested before a company commits to full production. That can help identify problems with materials, equipment, timing, or quality control while the process is still easier to change. Only after the design and production process have been tested is the product produced at full scale. So the finished car in this image, the Nissan Golf, is at the end of a much longer process, starting with an idea, then a design, constraints, prototypes, testing, pilot production, until finally it got to full production. IP. This last piece is all about intellectual property. Some valuable creations are not physical objects that can be simply locked in a room, but they can still be treated as property. Designs, inventions, and other original ideas have value because someone invested time, knowledge, and resources into creating them. Patents are one way of protecting IP, or intellectual property. The example on this slide uses the Volkswagen issues that I just made a joke about in the last slide. Volkswagen did not invent the general idea of a car, but a company can develop its own specific designs, systems, or inventions and protect those ideas from being copied by competitors or lie to the government. This connects back to the rest of the chapter because technology depends on more than scientific knowledge. Development also involves money, competition, design decisions, social demand, and rules about who can use an invention. By the end of the chapter now, you should be able to see that technology as a whole, from identifying a human need all the way to designing, testing, and production, use, and responsibility, is all one big bubble called technology. It's a process. You just learned it. Congratulations.